Hey friends, I'm Shaptarshi. I just completed my Masters in Chemistry from IIT Kanpur. And in this video series for IIT-JAM exam, I wanted to cover all the different types of numerical problems that come for physical chemistry. And by doing those problems, I'll be explaining the concepts as well. In physical chemistry IIT-JAM, 90% of your questions will be numerical based. So it's very important. And just like this video, I'll be making similar videos on different physical chemistry topics as well. So with that, let's get started with this one.
In this video, we will look at the numerical problems of thermodynamics, first law, and by doing these problems, we will get to apply all the concepts that we have learned in the previous video. If you already know the concepts of thermodynamics, you may not watch the video, but if you are weak in your concepts, you should watch that video. And by doing these problems only, you will be able to do the problems that will come in the exam, because as I have said again and again, it will be mostly numerical based. And over here what we'll do is, as I have said, all the different types. We won't do many problems, but all the different types of problems that we will do, so that in the exam, whatever problem you face, you can say that it is a known type, that you already know what's the type, just maybe some variations here or there. So let us tackle this problem and see how I'm approaching the problem. So that will also help you to solve some unknown problem in the exam. So this is, it's said over here, a 5-liter cylinder contained 10 moles of hydrogen gas at 27 degrees Celsius. So again, as I've already said, always write what's given. What is given over here? Your volume. Volume is how much? 5 liter. Cylinder contained 10 moles of hydrogen. What is this? N is equal to 10. Temperature is equal to 27 degrees Celsius, which is equal to 300 Kelvin. 273 plus 27, 300 Kelvin. Okay, so I'm writing the given things. Due to leakage, entire gas escaped in the atmosphere. Atmospheric pressure is 1 atmosphere. So P is given as 1 atmosphere. Okay, calculate the work done by the gas assuming hydrogen to be an ideal gas. So we can assume it's an ideal gas. What we need to find is work. W is equal to question mark. So I always say write the things that are given in the mathematical form. Half of, like, a lot of things that are done, and now we need to write the relevant formulas corresponding to those constants that are given over here. And so what is said over here is so let us read it again and try to understand what it is. See, sometimes you read the question and don't understand what's happening, so you just read it again and try to understand. Many a times it happens with me that reading the question 2-3 times helps me to understand the question and solve the question actually. So let us read again. A 5-liter cylinder was contained in 10 moles cylinder contained. So a 5-liter cylinder had 10 moles of hydrogen at this temperature. Due to leakage happened, and the entire gas was in the atmosphere, and the pressure was at 1 atmosphere. Calculate work done. So we know what's the formula for work. Work is equals to minus PdV, and we can integrate over here on this side. So over here pressure is like 1 atmosphere, so the pressure is already given, like it is a constant value which is of 1. So we can say that we can take the pressure constant and just say that it will be V2 minus V1, because pressure is not changing, pressure is 1. And we know that when pressure is not changing, we can use this formula. If pressure is changing, we need to use, like, integrate it totally. We cannot integrate it, we cannot take the P separately out, right? Then we need that minus nRT by ln V2 by V1 things comes. So what is also written, that is an ideal gas, right? So why is this information given? Because if you see, we know V1. What was V1? We know 5-liter cylinder contained this much amount of hydrogen, but due to leakage, we don't know the present volume of the gas. The previous volume was 5 liter, but the present volume V2 is question mark. So how can we, it's equal to question mark. It became a 0 actually. So how can we find our V2? Is simply by applying the ideal gas equation. So what is the ideal gas? You guys all know this. I'm not. PV is equal to nRT. So what is P? P is 1 atmosphere pressure into V equals to nRT. What is N? N is 10. R. So let us take R as your, so because we taking P as 1 atmosphere, we have to take R as 0.0821, and the units of R is over here, I think it's P V, so it should be your liter atmosphere per mole per Kelvin. Okay, so per mole per Kelvin, so I'm just writing per mole. And T, 2T is, I believe, 300 Kelvin, right? We saw, right? And so over here the V you will get, because we have all written the units in your liter atmosphere, and over here it is atmosphere. So if you guys sometimes get stuck, so I also forgot the units of R. You don't need to remember the units of R. You just need to know PV is equals to by NT is equals to R. So and PV, you know, liter atmosphere, and T is Kelvin. So that's how I just got the formula. And most formulas I don't remember actually. I know the equations, and I derive it from there. So it's very easy to do like that. So if you find V from here, okay, I'm not going to do the calculation. You just do it on your own, and you will see V is around equals to 246.3 liters. So this is V2, right? And now we need to know del V. What is del V? Del V is your V2 minus V1, that is equals to 246 minus 0.3 liters minus 5 liters, which is equals to 241.3 liters, right? So we know del V. So what we need to find? The work. So we can easily find the work right now, because we know work as pressure was constant. This will be V2 minus V1. Our pressure was 1 atmosphere, and our work will be in liter. This is 241.3 liter, and the answer we get will be equals to minus 241.3 liter atmosphere, right? And now that the trick comes, sometimes they will ask, say this, you have to express it in joule. How will you express this in joule? You should know this conversion unit, which is very much asked in thermodynamics, especially I've seen that 1 liter atmosphere is equals to 101.3 joules. So if I have to convert this unit in joule, what I'll do is your minus 241.3 into equals to your 1101.3 joule, and that will be equals to around let's say if I'm doing it in kilojoule, it will be equal to minus 224.4 kilojoule, right? So that was our first problem, a very basic one, but I guess you guys got some concepts out of it, the conversion unit and how to read the problem, how to approach the problem. Okay, if you found that easy, no problem, let's go to the next one. But if you found it a bit difficult, no issues, just analyze the problem one more time. Just analyze and see what's happening. Okay, visualize in your mind what's happening and try to understand. And when you understand it totally, it will be very easy. Okay, so let us go to the next problem. I'm covering all the different types. So there are 6 types of problems I saw that can come in this first law, and I'm covering all of them. In the next video, we'll do about second law. So thermo, guys, as you guys know, that thermo is very important. So let us look at this problem. First, again, read the question 1-2 times. Let us write what is given and what is asked. Calculate difference between the heats of reaction at constant pressure and constant volume for the reaction that is given, and the temperature is given in 25 degrees Celsius, which is equal to 298 Kelvin. And what do we have to find? Difference between heats of reaction at constant pressure and constant volume, which is constant pressure, the heat is what? Del H. Constant volume, the heat is what? Del U. And we already have studied in the last class. If you not getting the formula, please look at my video in the last video, that we already said del H is equal to del U plus del N RT. Do you guys remember that I said that del N will be only for gases, right? In the last video I told you. So del H minus del U will be equals to del N RT, right? So we need to find this difference, and del N RT is what we need to find. So over here we need to find first what is del N, right? So let us see what is del N equals to. It will be only for gases. There are 12 carbon dioxide which is in gas form, there is 15 oxygen which is in gas form. We won't consider the liquid form. Okay, so it will be 12 minus 15, which is equal to minus 3. So del N is equals to minus 3. If you didn't know that it was for gases, it would be a mistake and you wouldn't get the marks. You might even get negative marks, but okay, I don't want to scare you, so you should know it. And del H minus del U equals to del N RT. Minus 3 comes here. What is R over here? So let us use the value of R, like 8.314. This value let us use. And what else? So over here it is said in kilojoules, right? And this this formula of R is actually for joules, as you guys know. So no issues, let us just write in joule per Kelvin only. We could also write in 10 to the power minus 3 kilojoule, but let us just write in joule per Kelvin, and the temperature is 298 Kelvin, right? So if we solve this, let me go a bit down. we solve this, we'll get the answer as your somewhere around minus 7.43 kilojoules. Okay, so into 10 to the power 3 joules. So it was written actually in the, you have to read this very carefully. Actually, if you mess it up, your whole hard work is gone. It was written like give the answer in kilojoules, right? Very important words. So that's the second problem. I hope you guys understood it. Any problem, analyze it again. If you're not getting the formulas, like how did you get this formula, what all formulas are important, I have shown everything in the last video. Okay, so let us go to the next problem. Okay, let's see this one. 10 moles of a gas are heated at constant volume for from 20 degrees Celsius to 30 degrees Celsius, and we have to calculate the change in internal energy of the gas, and the molar heat capacity is given of the gas at constant pressure, that is 6.82 calories per Kelvin per mole, and R is given. So let us write what's given, as simple as that. Given is N equals to 10, constant volume, temperature goes from 20 to 30, so del T will be your 10, 10 degrees Celsius or 10 Kelvin, because the change will be same only. So let us write 10 degrees Celsius. Okay, so del T will be same, there's no change in the units because we're just calculating the change in it. Calculate change in internal energy of the gas. Molar heat capacity of the gas, Cp is given. Okay, let us just write it down, 6.82 calorie per Kelvin per mole. If we know Cp, we can know Cv because R we know, that is 1. So over here, note that everything is in calories. I will make a separate video expressing all the different units of R, in which case you should use what, of all the different units for energy and different conditions for STP, NTP and SATP, right? So over here we know Cp, and let us find, so let us see what is asked. 10 moles of gas heated at constant volume, so volume is constant. So see, when they're saying constant volume, we need what? We need Cv, and the Cv you can find out so easily. It is nothing but Cp minus R, that is 6.82 minus 1.987, which will be around your 4.8 calorie per Kelvin per mole. Okay, and I'm writing everything per mole. Okay, Cv we found out, and we know the change in temperature. Calculate change in internal energy of the gas. We need to find del E. So in the last video I have told you this formula of internal energy del U or del E, whatever is given sometimes. So del U, I have told you this formula, that it is equals to NCV del T, right? And N is given 10, Cv we know 4.8, and del T, what is del T? 10 degrees Celsius or 10 Kelvin. So let us take 10 Kelvin, like it's same thing only. So I'm not writing the units. So the answer of this will be equals to around 4.8, so around 480 calories. So that's the answer. And if like you're having any problem with the units, as I've already said, you should always put the dimensions and check the units. And one more thing that I saw, that the answer was actually given as 483 calories, and the reason for that, I believe, is, see, this is a very important point I'm going to make, so listen to it carefully. So this happens in IIT-JAM, that what sometimes, see, this 6.82 minus 1.987, or sometimes you have to multiply big numbers, right? And we just write one decimal point, and so this will actually be 4.83 calorie per Kelvin per mole. So it's better to write significant figures, right? It's always better to write 2 or 3 significant figures after the decimal point. Okay, even then what happens is, if you have seen the NATs, I don't know whether you guys know about this or not, NATs, they give you a range. Suppose 483 is the answer, they will say like 480 to 485 we will accept any answer between this. Every time in NAT they will give range until and unless the answer is like 1, 2, specifically 1 or 2. If it's a numerical answer, they will always give this range. So guys, this was a very big point that came out from this example, that you always write at least 2 decimal points after the decimal, write at least 2 figures, right, in your calculations. So I hope you guys understood it. This was quite an easy CP/CV, and from that we got the answer. So that was one type. Let us go to this next type of problem that is coming up. So over here the enthalpy change for a reaction is given, as you guys can see. I'll just mark it. enthalpy change for this reaction is given, and it is said that it is 30.54 kilojoule per mole, right? And entropy change is given, and what else is given over here is your calculate the temperature. So you have to, so this is the question mark. So let us first write as we do what is given. What is given is our enthalpy change. If you are very confident about this problem, you can pause the video and do it on your own. Del H is 30.54 kilojoule per mole. Del S is given as 0.06 kilojoule per Kelvin per mole, right? And pressure is given as 1 or 2. So we don't need pressure actually in this. Calculate the temperature at which del G is equals to 0. Del G has to be 0. It means an equilibrium position. Also predict the, so this is the second part. Second part we will do later. Always divide questions. Don't do everything at once. Take one thing at a time. Okay, very important in computer exams. Do one thing at a time. When you're doing this question, forget about the previous question. Even if you have not even been able to solve it, don't think what could have happened, this could have happened. No, you will mess that question, you will mess this question, you will mess your whole question paper. Done. If you cannot do, it's fine. JAM exam is not a very easy exam. There are a lot of questions you might not be able to do, but do what you can do, right? And later I will again make a video also about how to approach question paper. Anyways, so del H, del S is given. We know the formula for this. And how do we know the formula? I have showed you in the last video, and this formula I guess all of you know it already. So we have to know the temperature for which del G is equals to 0. So this is very simple actually. Del G you put at 0, del H you give the values 30.54 minus T. T is our it's our unknown 0.06, and from this we can get T as 5.09 Kelvin. And so this was the first part. Second part is important. Also predict, because this part also is mixed with what your chemical equilibrium, the Ley-Chatelard principle of it. Also predict the direction of reaction at a temperature below the calculated temperature. So suppose this is the temperature, and if your if it is below this temperature, so what will happen? So let us do it. Del G. So for this, del G is equal to 0. Now if T decreases, what does it mean? Let me take this blue color. Blue color. If T, blue color, where did you go? Blue color. So if T decreases, this will become more less, right? So this negative term will have a less power, less effect. A positive term will dominate. So if T decreases, del G will be more than 0. If it is more than 0, it is not a spontaneous reaction, right? Because del G has to be negative to be spontaneous. If it is not spontaneous, what does it mean? It will go in the backward direction, not in the forward direction. Okay, I hope you guys got to learn something from it. And with that, let us go to the other problem. And the last, I have a tough question, not a tough question, but a very standard level question. So these are all the different types of problems we are doing. Okay guys, sorry for this one, it's a bit hazy, but try to read it. Okay, you can read it very easily. Calculate the equilibrium constant for the following reaction at 298 Kelvin. Reaction is given. Del G of formation is given. Okay, this question is very important because it relates our del G with your equilibrium constant. What's the relation? Del G is equals to, at the standard state, right? Del G at the standard state is equals to minus RT ln K. How did I get this equation? I have told all the equations in the last class. So please have a look at that video if you are having problem. If you are not having problem, fine. Okay, so we need to know what is del G at the standard state, and I have already said what it will be is that the difference between the products and your reactants. Product and your reactants. Here we go. And so is it product and reactant is given? So if you see, the reactant side is given, product is not given. Why it is not given? Because I told in the last class that for elements the del G formation will be 0 by convention. So only the product will remain, only the reactants will, reactant H2O, because it's a compound, H2 and oxygen. These are both of your these are all your elements, and this will be like 0 by nature, by convention. So but just for clarification, I will show you how to write this part, because suppose it's not an element, it was a compound, then how would I write? Because you need to take the stoichiometry into account. So you have to write like this: del Fg dot of H2, right, plus del Fg dot for oxygen minus, so we wrote the product first, now we are writing the reactants. So this will be in one part. Let me take another bracket just for clarification, because 2, why I have 2, because stoichiometry is 2 over here, right, minus 2 of del F G dot of your water, and over here we have it. So let me go a bit down. Okay, great. And now we know that this part will be 0, this part will be 0, only part surviving is this minus 2 into what is the value for here, it is minus 237.2 kilojoule per mole, right. And so we are getting this as 474.4 kilojoule per mole, right. And so we have got this del G value, and now what we need to find is our K, equilibrium constant. So let us put this equation in the first part, what we will get. So let us, I'm just directly writing it, okay, in the one, this is the equation 1 that I have written, and in 1 if I replace it, what will happen. So let me just again write it down for your clarification, and I will have to convert it to the log form, because or you cannot convert it also, okay. If you want, you can directly put this because you have a calculator, right, you can directly use this form. Otherwise you can also write in the chemical kinetics also, we will be doing in the next part only, I believe. There also you need to sometimes convert this portion to the log base 10 from the base E, right, you should know what it means. And so 2.303 into R. So what is R over here? It is very simple actually, it is 8.314 into T. What is T over here? T was how much? T was over here 298 Kelvin. Yep. And so I'm not writing the units anymore, into log K. Okay. And if you do this equation, I'm not doing it totally, but if you do and find K, ultimately you have to take anti-log. Okay. So how to take anti-log? You have to press the shift button. Okay. Just try it in your calculator. Don't try it in your what do you say? Don't try it in your calculator that you use by hand. Try it once in the virtual calculator. You have a virtual calculator in your what do you say, your in the online site. I will just show you. Let me see if I can share the screen or not. Virtual calculator, everyone can access it actually, it's for free. Scientific calculator, TCSION. So try it once over here with this anti-log, and so this will be 10 to the power x, right. So that's why I was, so can I write something here? No. So this portion, can you see this portion guys, 10 to the power x, I'm writing power to the power 10, because why? So I'll just show you, okay, because this is very important. A lot of people do not know how to use anti-log and all these things. So see finally what I'll get. So let us write log K. Del G is what? I forgot the value of del G. What did we find as the value of del G? It was 474.4 kilojoule per mole. So our log K will be 474.4 kilojoule per mole. Okay, remember this value is in joules per Kelvin per mole. So it's a very good method actually. I'm doing it quite fast for your understanding, but it's a very good policy that you write all the units while you're doing the numericals. You won't ever make a mistake over here. So 8.314, let me write in 10 to the power minus 3 now, because I'm converting to kilojoules per Kelvin per mole into 298 Kelvin. So if you do this, let me see, the value will come around minus 83.14. So your log K value will come as minus 83.4. So what will be K? Your K will be anti-log of your base 10 minus 83.14, that will be equals to 7.24 into 10 to the power minus 84. So now I will check this out on my own in front of all you guys. Let's see whether it actually comes or not. So this should be the value that's coming. Okay, this answer I got from the book only. Okay, so let us see if it actually comes in our calculator or not. Antilog of minus 83.14. So let us just remember this value, minus 83.14. I will do the antilog. For you guys who do not know how to use antilog, let me do it. 10 C minus 83.14. So if I'm not wrong, after a long time using this calculator, but you always have to write or value before it. Minus 83.14, 10 to the power x. Oh yes, it came. 7.244 into 10 to the power minus 84. Is this the answer that we got also? 10 to the power minus 84. Yes, that's the answer. So that's, guys, how you use antilog. And suppose you had used your, what do you say, ln, the ln function, you have to use e to the power x. In that case, over here you can see the mouse cursor. You have to use e to the power x. Okay, so you guys understood this also. Great. This is very important, not only for thermodynamics but for other calculations as well. Great stuff. So let us come to this last problem. It's a very important problem, guys. This is a very standard level. It is a bit on the tougher side, I will admit, for IIT-JAM. This time IIT Roorkee is conducting it. So one thing I can assure you, I'm very confident of this, that this year's exam will be easier than 2021, the last year, because that was by IISc. So this time IIT Roorkee, I'm definitely sure, but cannot say for sure, but I'm totally confident that it will be easier than 2021. It will be, I believe the level of the paper will be around 2019 paper. And so last year it was very tough. I'm very sure it won't be that tough. Okay, and so whatever it is tough, it's easy, don't get discouraged. You do how much you can do. If it is tough, it's tough for everyone. If it's easy, it's easy for everyone. It's not an exam where you do well or do bad. It's an exam where you do better than others. It's a competitive exam. Let us read the problem. 2 moles of an ideal monoatomic gas, initially at 100 degrees Celsius, temperature given, 5 atmosphere pressure given, expands adiabatically and reversibly. Adiabatically and reversibly, main points to note, and I told you formula for this, guys, that PV gamma equals to constant. Okay, and over here what we have, at and reversibly at 2 atmosphere. Calculate work done. Okay, so if it is adiabatic, our Q is 0, right? And calculate the work done by the gas. Okay, so what we can do, so temperature and pressure is given, and if you see pressure, like the P1 and P2 is given. So T1, if we say is 100 degrees Celsius, which is our what, 273 plus 100 is 373 Kelvin. P1 is 5 atmosphere, P2 is 2 atmosphere. We need to convert this PV gamma to T and P form, and I told you in the last video how to do this, simply by PV equals to nRT method. So I'll do it in front of you to show you guys. It is very simple. So we need our T and P in the equation, right? Because T and P is given, so we need to replace V. V is what? RT by P. So let us replace this, and so if I write P1 V1 gamma equals to P2 V2 gamma, right? Gamma is Cp by Cv. I have told everything in the last video, right? And let us do this. V is RT by P. P1, it will be R T1 by P1 whole to the power gamma. P2, so n I'm not taking because n will get cancelled, even R will get cancelled, right? So that's why I should have taken anyways. R T2 by P2 to the power gamma. Okay, so R will get cancelled, T1 P1 will remain, and that will be our equation. That will be our equation, right? So what will our equation be? P, so it will be P1. So gamma is below, remember? So I'll just do every step, guys. Okay, because sometimes we think before and write it down. Very silly mistakes, just because we don't write the steps. Always write all the steps. So this will be what? It will be, let me write T1 gamma and P1 1 minus gamma equals to our T2 gamma, P2 1 minus gamma. And is the value of gamma given? Okay, the value of gamma is not given over here. So, but one thing is given. You see, it's given it's an ideal monoatomic gas. And for our ideal monoatomic gas, we can actually find our Cp and Cv. This is a very good problem, guys. A very amazing problem for the ideal monoatomic. So I'll do a problem on gases also, where you will get to know that for ideal monoatomic gas, Cv is equals to your 3 by 2 R. Sorry, 3 by 2 R. If Cv is this, Cp will be equals to your Cv plus R, which will be equals to 5 by 2 R. And your gamma is what? Gamma is Cp by Cv, which is equals to 5 by 2 R divided by 3 by 2 R, which is equals to your how much? 2 gets cut, 5 by 3, right? So this is it. And so we will have to just now replace everything because we have everything now. And so our T was how much? T1 is 373, P1 is 5, P2 is 2. Okay, good. Let me just replace this in this formula. So this is the formula where we will replace 1. In 1 we replace it. T1 was 373, gamma is 5 by 3, and P1. So over here, if we actually write all the power separately, it will become a bit tough. So I'll just show you how to do it. You can simplify it, and in the end you put all the values. So let me write so the best way to write this problem will be your suppose we need to find T2 is what we need to find, right? So T2 gamma is equals to T1 gamma, P1 1 minus gamma, P2 1 minus gamma, right? So this is what we get. And now what we can do is for P1 and P2 we can club them together, right, and write 1 minus gamma. So T2 gamma equals to T1 gamma and P1 by P2. This will be your 1 minus gamma. And so we need to find T2, right? So T2 will be, I'm just taking this like power, so I'm just dividing by this power of all the equations, and this will be your T1 in that case. So I'm like, you can say I'm square rooting. So suppose it was T2 square, right, equals to T1 square and P1 P2. So if I'm square rooting, what will happen? The square will go out, and this square root will also go out, and for P1 by P2 this will be like to the power half. So that is what I'm doing. So I'm just square rooting with this, not square rooting, but I'm just rooting with this power, and P1, so I by P2 this will be 1 minus gamma by gamma. Okay, so now you see that we can input it so easily. So what was at T1? T1 was 373, P1 had the value of 5 atmosphere, and this was 2. I will again just check it, okay. And gamma also, I forgot what we found. Gamma was 5 by 3, I believe. So let me just check. Yes, P1 is 5 atmosphere, P2 is 2 atmosphere, gamma is our 5 by 3. So 5, so everything is right only. So 1 minus 5 by 3, I'm just writing the value, 1 minus gamma, 1 by 5 by 3. So this will be 3 minus 5, which is minus. So just for your sake, okay, I'm writing every step. You also write every step, okay, don't do the silly mistakes. You know every concept, you know everything. Why do you want to make silly mistakes, right? You should not make all these silly mistakes. So this will be equals to 2 by 3. So this is equals to minus 2 by 3 divided by 5 by 3. So 373, 5 by 2. If we do the division in the top, this will be minus 2 by 5. Is this the answer? So if you do this again, use a calculator, okay. So this is very simple, I won't show you. because you have to just do like 5 by 2 and to the power of minus 2 by 5. So this is actually pretty simple, and if you do it, the value will come around, the answer is given around 258, around 258 Kelvin. So we found T2. What was the question? Question was, we need to find the work done. It is an adiabatic process. It's an adiabatic process. Q is 0. So our internal energy, you know, this is N CV dt. Q is 0. First law, what it says, Q plus W. W equals to N CV dt. You understood how? Q we put at 0, del U is equal to W for this case, and so we just replace this. So N is what? I think 10 moles. So 10 moles were taken, and CV was 3 by 2 R dt. So it's the change in temperature actually. Okay. So okay, when I'm writing delta over here, I should also write delta over here. Otherwise, okay, because notations are different for that. So we will now replace all the values over here. So N is our 2, CV for our monoatomic ideal gas is 3 by 2 R, del T is 258 minus 373 Kelvin. Okay, and if you do this, R you replace in 0.0821 liter atmosphere. If you do this, the answer, do it and check, answer should come around 28.2 liter atmosphere. Okay, and so that was our work done, we found out. So let us see what was the next question. It is said, find the final volume. This is very easy actually, because we already know it's an ideal gas, so we can easily find the final volume using part 2. We know P2, we know V2 is to be known, nRT2. V2 will be, N will is 2, R is 0.0821 liter atmosphere. T2 came out as 258.4, and our P2 was how much? P2 was 2, I believe, right? P2 was 2. So if you do this, the answer that is given will be around 21.2 liters. So just check it. Just check the value of P2 once. I forgot the value of P2 that was given. P2 value is 2 atmosphere, right? So final question we have is change in enthalpy. Very easy again. Is del H equals to NCP T2 minus T1. So you see, we have all the things we know. We know T2, we know T1. CP, how we know? From the ideal gas we know, and we found out also N is 2. CP we know that it is 5 by 2R, and you put the values of T2 and T1. So T2 will be how much? T2 was 258, right? This was around 373. So you do this also, and you found the answer around your my answer is given as minus 4753.87 joules. You will find it around this range. You might not get the exact answer, but try to get the answer in the range of in a good range. Try to get with as many precision as possible, right? If it is not exact, also you will get the full marks if it's in the range. And the examiners, they know the range, so you don't need to worry too much about it. And okay, so that was the problem about adiabatic reversible process, how we found out, how we derived it, how we did the whole thing. If you have some problem, see my last video or try to see this video only again and try to analyze. If you have some problem, comment in the comment section. I will try to answer it. And in the next video, we will see about the second law. So guys, in this video, we saw all the different types of problems. I again told you all the different types. If you analyze all these types only and practice one more two from other areas, you should be able to do 90% of the questions, right, that come in the physical chemistry, thermo part or this part, whichever part you're doing. I'm always solving all the different types. Okay, there may be always one or two unknown questions no one knows about it, but these are the types. Even I studied like this. Okay, so I'm just sharing everything with you. Okay guys, so with that, all the best and see you in the next video. God bless you.